This is an example of how to do a Heaviside function. I've had a little difficulty with these in DiffyQ, and I thought maybe I'd try to pass what little I've learned about them onwards. They are composed, in my opinion, of two stages. You have a translation stage. In this case, we'll be translating from a piecewise function into a Heaviside function. And then you have your Laplace transform stage to get the final solutions. So in this example, we have a piecewise function f of t, and it equals 1 when t equals from 0 to 2, and f of t also equals t squared minus 4t plus 4 when t is greater than or equal to 2. And the best way to think of the piecewise functions is a main function, your f of t or x of t or f of s or anything really. It's composed of individual subfunctions. In this case, we're saying f of t is composed of some f1 of t and some f2 of t. And it could have a number. It could be up to 100,000 functions, subfunctions, but whatever that little number after the f is indicating how many little subfunctions there are, or which one it is too. So our first step is we're going to translate our piecewise function into a Heaviside function. And a Heaviside function has this form: u sub c of t all times f sub n of t plus c. Actually, it really doesn't have the little n in there, but I put it in there to help us remember that, hey, it's a piecewise function, and we have to consider all the little components that go into our main f of t function. And that little c, which is blue there, you can see, it indicates the step. The step indicates where we are inside this function. In other words, if the time is 0, what part of the piecewise function are we talking about? If the time is 1,000,000, what part of the piecewise function are we concerned about? And then the little n is indicating that little subfunction. So to translate, let's look at the first thing. Well, f of t, our whole function, equals the Heaviside function of f1 of t, right? To write that, we put u sub 0 of t, f sub 1 of t plus 0. The zeros are our step, so when time is 0, that's our step. And the f little 1 shows us that, well, we're adding in to our main function, we are adding in f1, right? Well, this is interesting because now we actually have to take f1 back out of our function. The reason we do this is because f of t equals 1, right, when t equals from 0 to 2. But it doesn't equal 1 when t is greater than or equal to 2. If t is a trillion, f of t doesn't equal 1. It equals t squared minus 4t plus 4. So the way we translate these piecewise and the Heaviside functions, we might add some things and we might have to take them back out. And that's because it doesn't equal certain things at certain times. F of t doesn't equal t squared minus 4t plus 4 when t is 1. It equals 1. And then f of t doesn't equal 1 when t equals 3. It equals t squared minus 4t plus 4. So that subtraction, it's not much. It doesn't look like much, but it's important because you have to understand that in order to get the solution. And then our last thing for translating is we need to add in what f of t equals once our time does hit 2. So the step it's like a switch. And when the switch gets turned on, you have to do certain things. You have to take some things out. You have to put some things on. In this case, we had to take out f1 of t, and we had to put in f2 of t. And then you just follow that formula. To actually translate it, it's u sub c, or u step 2 of t, times f sub n, which in this case, it's our second individual function of our piecewise, all times t plus the step, which is, in this case, 2. So at 2, that's when that step happens. That's when we add it in. So we translated it, but now we need to transform it. We need to get our solution. And to do that, we use a Laplace transform. It's not too hard. It's really just plug and play, though you can get into some tricky stuff, depending on how complicated your functions tend to be. So here we see that n is showing the function, the individual function of our piecewise, and the c is the step. So here's the original translation we just went over. I'm rewriting it so we can see it. And we are going to now transform it using Laplace transform. So the Laplace transform of our first one here, our first Heaviside function, you just plug and play. So u sub 0 of t, the hard part is really translating. And now you just put in those numbers from the formula. So the little blue O's, the little blue zeros come from that negative CS or turn into that negative CS. So you have e to the negative 0s or just e to the 0, which is just 1, all times now the Laplace transform of our individual f1 function of t plus the step size of 0, or just f1 of t, right? Which in this case, f1 of t equals 1. F1 of a billion actually equals 1. F1 of t plus 1,000 equals 1. F1 of t always equals 1 because it actually doesn't depend on t at all. So now we're going to subtract out f1 of t in order to make the whole function make sense. And to do that, you just plug and play. You plug in the step. In this case, the step is 2. So at time equals 2, something new is happening. The function no longer equals f1 of t. It equals f2 of t. So we actually have to get rid of f1 of t, and that's exactly what we're doing here. And if you look, f1 of t plus 2, it still equals 1, right? Because f1 of t doesn't depend on t, even though we write that. The last thing we need to do is add in what the function of t equals when the time hits 2. It actually does equal, it doesn't equal f1 of t, but it equals f2 of t, or it equals t squared minus 4t plus 4. And here, this function does depend on t, so wherever you see a t, we're going to put in t plus the step. In this case, the step is 2. So t squared minus 4t plus 4 turns into t plus 2 squared minus 4 times t plus 2 plus 4. All right, so now we're almost there. All we have to do is these final Laplace transforms. For the first one here, the Laplace transform of 1 is 1 over s. Pretty simple. The second one here, the Laplace transform of 1 is still, it's 1 over s. And then the third one, we're going to do a little bit of algebra. Here, I read it out. Most of this stuff actually cancels out. Actually, almost all of it cancels out. And we end up with e to the negative 2s times the Laplace transform of t squared. Well, the Laplace transform of t squared, I think I write it right here. It's, I think it's what is it? 1 over s cubed? Right. Did I do that right? 1 over s cubed. Oh, sorry, it's 2 over s cubed. Okay. The Laplace transform of t squared is just 2, or n factorial, or 2 factorial over s all up to n plus 1, which is 2 over s cubed. And then this simplifies down to 1 over s plus etc., etc. I hope this video helped you, and if you liked it, please give me a thumbs up. Thank you.